Welcome. I hope you're enjoying learning about codes and how codes, of course, help simplify designs. We're going to be talking about construction types, and it is chapter 3 in your book. So, if you will, open up your book and look at the construction types, or also look at chapter 6, and that's kind of where we're going to begin on types of construction. Okay, one of the things, if you look under chapter 6, types of construction, you'll be able to see we're going to end up looking at our PowerPoint here. I'm going to get it going so that way we'll be able to see what we're doing. And we're going to talk about the different types of construction types. Construction types are a major factor on interior projects. Of course, you have to determine. Remember, first we had to figure out, of course, what our classification is. We're figuring our occupant load based on the square footage, and so we're trying to go through now and determine what type of building materials do I have to use to be able to accommodate that many people in that facility. So it plays a real major factor on interior projects too, especially when we are reconfiguring building elements or relocating walls, making changes to the floor. All of those are important for us because that will make a difference on what we can do, or if we have to add stairs. So we've got to be familiar, because if a particular building has a particular construction type, then we have to maintain that. We can't just go and change something, because that would change the whole construction type for the entire building. So we've got to be familiar with those so that we'll be able to understand that. So every building has building elements, and they also have structural elements. And so you ask a lot of times, what is the difference? Can they be both? Yes, some can and some cannot, but construction types are stricter than others that you will see. Let's go over a little bit of the terminology. Non-combustible materials are defined as materials that will not ignite and burn. But a lot of times they may be subjected to a fire, and they don't contribute to the fuel of the fire, but things can happen like steel and iron. If you get a fire that's so hot, it could bend or melt some of the steel and iron. May not be that way for concrete or masonry, but it could crack some of those. Combustible materials will ignite, and they continue to burn when a flame source is removed, kind of like wood. But there's all different types of materials that you will see. Unprotected indicates the structure or building elements of a building that has not been treated in any additional way to increase their fire resistance beyond the natural characteristics of the material. So we're going to end up learning a little bit when we look at Table 601. If you opened up your code book on Chapter IBC Code Book, page 107, Types of Construction, you're going to learn a little bit about non-protected or unprotected and protected. Protected indicates that the structure elements of a building have been treated to increase their fire resistance. So if they're treated, then therefore the longevity of that material, of course, will be much more protected. Fire resistant refers to construction materials, assemblies, and textiles that prevent or retard the passage of excessive heat, hot gases, or flame. So you're going to find there's fire resistant materials that will not burn. They'll end up be kind of more of a material that will prevent a passage of heat and flame to continue on. Then there is something called limited combustible. refers to material that is not considered non-combustible yet still have some fire-resistant qualities. And this is kind of a term that's used by the NFPA, which is the National Fire Protection Assembly or Association. Okay, we're going to look at some terminology here, and y'all need to kind of look at that because I want you to understand what building height is. That's kind of, and I'm going to show you in the next slide, of course, some of those. Building height is the vertical distance from the grade plane to the average height of the highest roof structure. And I'll show you an example, and you can see that in section 504 in your IBC book. Story height is the clear vertical distance from the finished floor to the finished floor above, or finished floor to the top of the joist supporting the roof structure above. And then the area building is the amount of floor surface included within the exterior walls, exclusive of vent shafts or courts. And you can see that, of course, on page 95 in the 2012. So let's look at this diagram that I have here. It kind of shows you when we're talking about the story height is measured as the vertical distance from the top of one finished floor to the top of the next. Okay? That's what we're talking about, from here to here. So you figure, of course, whatever this plenum space, and a lot of times they call this a plenum space that's here. And then to the top of the ceiling joist, okay, then to that finished floor. Then if you have a basement for like sloping grade level, that you would figure it here from the center because it would be half of this. And then of course it would go from here to here. Okay? So if we're figuring the total plane or the total height of the building, it would go from the center here. If there was a slope, then it would go to there. If it was flat, it would go to the top. Okay, so that's kind of how you figure story heights, and of course building heights, the vertical distance of one. Okay, building elements. Just so that you kind of understand, building elements are parts that make up the building. It's the columns, the floor systems, ceiling systems, interior walls, and vertical shafts. Those are building elements. They're not necessarily structural elements that's holding the building together. Structural elements are parts of the building that support the building itself and its contents. Without them, the building would fall down, which would be like your columns, your girders, your trusses. Now, there's different types of constructions, and usually there's 5 different ones that we talk about, and we'll learn about those in a little bit. Type 1, Type 2, Type 3, Type 4, and Type 5. But they're defined by the materials that make up the structural elements and the fire-resistant ratings for each essential building element, a minimum hourly fire-resistant rating. Materials are allowed in each of the construction types. They're either non-combustible, limited combustible, or of course, combustible. Now, this one, of course, is kind of showing you what the NFPA or Life Safety Code kind of looks at. And that kind of right there is a little bit different, but I just wanted to kind of show you these because they look at it as non-combustible and combustible. And the HP, which you see here, of course, means highly protected. P means protected. UP means unprotected, and HT means heavy timbers. And their non-combustible is, of course, their construction type 1 and 2. And then they have construction type 3 and 4. And the least resistance, of course, is construction 5. Okay, so combustible versus non-combustible. When we look at it, the length of time of material has to be resistant to fire. Resistance is based on how easily they ignite, how long they burn once it's ignited, and how quickly the flame spreads and how much heat the material generates. Products are differentiated as either non-combustible, fire-resistant, limited combustible, and combustible. So when we talk about non-combustible materials, remember that they will not ignite, they don't burn, they don't release flammable vapors, and they're required to pass the ASTME 136 standard test method for behavioral of materials in a vertical tube furnace at 750 degrees Celsius. Non-combustible materials would be steel, iron, concrete, and masonry. Combustible materials that will ignite and continue to burn when the source is removed. So if we put a flame or a match up to something, and they'll burn. There are fire-resistant materials once treated will delay the spread of the fire for a designated time period. Like heavy timber, fire resists because of the size. If you have an 8x8 column or a 6x10 beam, you will notice you can put a little flame to it, but it's going to char, and the char is going to build up, but it usually will not just burn. It's just kind of like putting a big log in the fire. The way to get that big log to finally burn or char is putting a bunch of little ones there, building up, of course, the heat. Buildings to have minimum fire-resistant ratings is based on the table 601. So if we look at this table, and you can see here, 601, and we're looking at it right here, you can see it talks about type 1, type 2, type 3, type 4, and type 5. And you can see it talks about primary structural frame, bearing walls, exterior and interior, because sometimes you're going to have exterior load-bearing walls and you're going to have interior bearing walls. Sometimes you have to have an interior bearing wall to hold up the ceiling structure that may be going around. And then you have non-bearing walls or partitions, which could be, of course, on the exterior, and it says see table 602, which we'll go to. And then non-bearing walls and partitions on the interior. You see floor construction and associated secondary members. Remember, go back and look at what are secondary members. And then you have roof construction, associated secondary members. So those are things that you kind of have to look at. Can a designer reduce a building's classification and safety and affect a building's insurance and liability? You bet. Not specifying the correct rated materials or assemblies can make a difference. So when I use the word assemblies, that's talking about the whole component. What is it? If it's steel and we wrap concrete around it, that's one thing. But then if we go through and we put a wall that was load-bearing, we take out part of the wall, and we come back with something that is not fire-resistant, yeah, we can totally change the rating. So let's go back and look at this table. We can see it, of course, in our book, but I just want you to make sure and look at what's below. You see what's below. Roof supports. It goes through what can be used and what is not used. So look at this on that. But I want to kind of go over what are the different types. Type 1 and Type 2 constructions. And you'll see that information if you look on page 107. It kind of describes what those requirements are. Types 1 and 2 constructions are those types of construction in which the building elements listed in table 601 are of non-combustible materials except permitted in section 603 and elsewhere in the code. So you have steel and concrete construction. Type 3 construction, that's type of construction in which the exterior walls are non-combustible materials and the interior building elements are of any materials permitted by this code. So that means they may be fire-retardant treated wood. Throughout more, you'll find experience like a salt compound that's going to be put on it so it won't rot and it transpires on it, shall be permitted, and the X within the exterior wall assemblies have to be 2-hour rating, okay, of that or less. Then we have type 4. Type 4 is heavy timbers. Heavy timbers, of course, are those big logs, and you're building your concept of your structural frame out of heavy timbers. And they usually have to be fire retarded, treated wood framing, and they have to comply with the other materials. Then you have, of course, if you're looking back in your book here, you can see in through here, we have type 5 construction. That type 5 construction is kind of your stick buildings. Stick buildings that you see that are constructed with elements, structural elements, exterior walls and interior walls, or of any materials permitted by this code. And a lot of times you'll see that where people will call it stick buildings. So kind of looking at this, I just want to kind of give you an overview. We're going to go back over this particular table and really dive into it. To kind of compare the two, you're going to see, of course, the ICC code. This is a 2009, but it talks about 1A, highly protected. But I want you to know, because if you get to working with somebody and they say, well, let's look at the NFPA 220 standard, you're going to see there's a little bit different. They have this 1, 1, 2, 2, because that's protected. Type 1B protected, type 2A protected, type 2B unprotected. And so here are these numbers. So what are these numbers? If you look down at the bottom, it says they're a 3-digit code. And their first number, which would be this first number here, we looked at a type 3B unprotected. The first number 2 is your exterior load-bearing wall. That means they would have to be a 2-hour rating. The second number is the frame, columns and girders and stuff. That's the hourly rating that you see in the second number. And then the third is the floor construction. How is it rated? Okay, so this is the numbers, and that's what it means. Okay, we're going to stop here and let you take a rest, and I hope that this kind of starts explaining. If you haven't read the chapter, make sure you read it.